Yet again, have you at any point pondered what our Sun resembled when it was an exceptionally youthful star? The James Webb Space Telescope has created a staggering revelation about our Sun. For the first time, we can see our star in an entirely different light. The JWST's most recent disclosure offers entrancing insights into the young periods of stars and the massive cycles that might have occurred in the early stages of our Sun. Have we now opened another of the great secrets of the universe thanks to the new James Webb Telescope? What mysteries still await us out there in the universe? The James Webb Space Telescope is a perfect representation of the advancements made by cutting-edge technologies. Since the telescope was launched, the investigation of the universe has advanced at a rapid pace. With its most recent mission, the JWST has demonstrated its remarkable ability to delve deep into the secrets of the universe. Once again, the telescope exhibited its absolute technical superiority when it imaged the object HH21 with great splendor. HH21 is also called a Herbig-Haro object, a very young star yet advanced enough that it's blowing strong jets into the universe and beginning to shape its surroundings. Since its study by the JWST, the object has provided an abundance of significant data about the youthful phase of stars and, consequently, the early stages of our own Sun. These observations furnish us with crucial information about the processes that occur during the initial phases of stellar evolution. Herbig-Haro objects are among the most fascinating astrophysical phenomena in regions of young stellar evolution. They consist of narrow jets of gas shot out from newly formed stars and streaming into the surrounding interstellar space at high speeds. These jets collide with surrounding gas and dust, resulting in dramatic emissions. Herbig-Haro objects were discovered in the 1950s by astronomers George Herbig and Guillermo Haro, who were independently studying star-forming regions and initially observed the significant outflows well before the JWST era. The energy-rich jets from the center of a young star are astounding. Who would have thought things would be so violent in the stellar nursery? Young stars are everything but cuddly. They are indeed beautiful but also incredibly powerful. We can barely imagine the forces at play here with our minds alone. The forces that lead to the formation of a star are immense. And even in the initial billion years, things heat up around a young star. It takes countless years for a star to eventually shine as calmly and steadily as our Sun. The object of the latest observations, the Herbig-Haro object HH21, is situated in an active star-forming region in the constellation Perseus, about 1,000 light-years from Earth. HH21 is particularly intriguing as it is one of the youngest and closest examples of these objects, making it an ideal field of study to investigate the physics of star formation in detail. The discovery also provides us with magnificent views of the dynamic processes that likely occurred in the early stages of our Sun's life. The JWST has imaged the Herbig-Haro object HH21 with remarkable accuracy, offering even more fascinating insights into what was once impossible to see. For the first time, it might even be possible to see a double star forming at the center of HH21. The images reveal two brilliant, high-energy jets emanating from a central point. These jets are enriched with particles like carbon monoxide and silicon monoxide and are evidence of high-energy processes within the star and its immediate environment. The discovery of molecular hydrogen within the jets was a major surprise and now provides a completely new picture of the chemical structure and thermodynamic conditions in the early stages of star development. The surrounding accretion disk of the young star, where other objects such as planets and moons might also form, could be affected by the extreme emissions from the jets, making the formation of stable bodies more challenging. Nonetheless, the JWST studies also showed that the jets of HH21 are slower than those of many other Herbig-Haro objects. This slower speed could indicate that the star is at an early stage of development or that the processes in this young system are generally less tumultuous than in other stellar nurseries. The ability to observe such key cosmic processes up close and with high accuracy represents a significant advancement in cosmology and will lead to ever more exciting discoveries in the future. Observing the birth of new stars also provides insights into how ionized gases and plasma interact. The energetic jets that impact the cold surrounding interstellar medium create radiant shock fronts that act as visual boundaries of the young star systems. These early outflows of a star are akin to the protective shell of our Sun's heliosphere. On a scientific mission with the JWST, researchers are excited about the additional possibilities. The JWST is equipped with a range of innovative scientific instruments, including the Near-Infrared Camera (NIR-CAM), the Near-Infrared Spectrograph (NIR-SPEC), the Mid-Infrared Instrument (MIRI), and the Fine Guidance Sensor (FGS). These instruments can detect even the faintest light from extremely young and distant objects that would otherwise be invisible to our eyes. By using infrared technologies, astronomers can now see through dust clouds to uncover previously hidden corners of the universe and gain direct insights into young stars and their formation regions, often obscured in thick dust shells. Thanks to the high sensitivity of the JWST, astronomers and space enthusiasts alike can enjoy a level of detail that has never before been achieved in the history of astronomy. The JWST can not only image these faint light signals but also analyze them. Never before have scientists been able to see so much detail of the massive jets and precise studies, providing information on the evolution and temperatures of the gases, as well as details of all the chemical elements and molecules involved. Herbig-Haro objects, typical of dynamic star-forming regions like the Orion Nebula or the constellation Perseus, are valuable for studying chemical processes in space. These regions are rich in gas and dust, offering ideal conditions for star formation. Stars are formed from the accumulation of these collections of matter influenced by massive forces. The jets ejected by young stars, which travel through space at velocities of several hundred km/s, are just part of the dynamic processes that occur during star development. When these jets impact the surrounding medium, they heat it up and create the characteristic brilliant arcs and clusters visible through our telescopes. Within this vivid display, enormous physical forces are at work, as well as a light show of the elements, along with electrical and magnetic forces. Captivating observations reveal how the jets interact with the surrounding material, helping to shape the cloud from which the star is formed. Each beam of light and each color gives the JWST and thus the scientists valuable clues about what is happening here. Observing these processes live and in their early stages is like getting a direct glimpse into the blueprint of a star. If we understand how matter is integrated into the cosmic circle, how the final mass of a star is determined, and which elements and gases are involved, we can draw significant conclusions about the forces at work. This, in turn, helps us understand the overall matter formation processes in the universe. Although we can imagine that star formation is one of the great energy processes known to humankind, it is hard to grasp that such a young star can produce winds extending several hundred light-years and blow them into space. The jets of the Herbig-Haro objects could be direct remnants of the tremendous angular energy that causes dust disks to begin to rotate and coalesce in the center. Nonetheless, it is possible that the young star uses the jets to expel the forces it no longer needs while simultaneously driving developmental processes in the gas and dust cloud and star systems. So far, we have only observed jets in young and actively forming stars. However, we also know of very old galaxies in the universe that also produce powerful jets in their active centers. Some of these cosmic winds extend far beyond their galaxies. These winds likely also disperse enormous amounts of material, which ultimately influences the mass of the star and the environmental conditions of the star-forming region. The material and energy expelled then drive further star births or other elements in the universe. Let's consider for a moment the role of magnetic fields around a young star. Magnetic fields are crucial for controlling the accretion process in which the star attracts gas and dust from the surrounding disk, and they also influence the direction of the jets. Magnetic fields are not only significant in the immediate vicinity of young stars but are present throughout the universe. These invisible forces direct the paths of charged particles and influence the shape and development of entire star systems. In our own solar system, the magnetic forces mediated by the Sun's magnetic field are essential for maintaining the heliosphere, the bubble that protects the entire solar system from harmful cosmic rays from interstellar space. The Sun itself generates a complex and variable magnetic field that determines the order of our solar system, influences planetary atmospheres, and regulates space weather patterns. Sunspots, solar flares, and coronal mass ejections are signs of the Sun's magnetic activity. As you might know, such events sometimes significantly affect the operation of satellites and communication systems on Earth and produce auroras. The study of magnetic fields and young stellar systems like HH21 is an exciting field of research and is still in its early stages. If we understand the development of stars in distant regions, we can also gain insights into the history of our Sun. Our star is 4.5 billion years old and has undergone many changes since its birth in a cloud of dust and gas. The beginnings of the system also determined how planets were formed, from the solid Jupiter to the rocky planets, including our Earth, various gas giants, and small planets like Mercury or Pluto. They were all somehow present in the early stages of the system, or their distinct conditions helped shape the formation of the planet and consequently the vast environment. The study of the universe through advanced telescopes like the James Webb Space Telescope, JWST, opens windows into the deepest corners of space far beyond what was once possible. Each new discovery broadens our understanding of the universe, and the JWST is a key instrument in unlocking the secrets of the cosmos. These observations bring us closer to understanding the birth of stars, the processes of stellar evolution, and the larger cosmic picture that shapes our universe. As we continue to explore the universe with the JWST and other advanced telescopes, we'll uncover more mysteries about the early stages of our Sun and other celestial phenomena. The future of space exploration promises even more fascinating insights into the origins and evolution of stars and the universe as a whole.